Good afternoon, everyone. By now you've seen the massive eruption. Shockwave felt across the entire planet. And during this eruption, lightning strikes through the ash cloud. Overlapping time of clouds electrically charged and all losing their charge at the same time. If it's anything like Pinatubo, and they'll have to increase the volcanic explosivity index, cooling 0.3 of a degree. Winds going west from Tonga, 2,500 miles, northern Australia. These catchment basins are going to be inundated with ashfall. Those animals will not eat ash-covered plant. Tropospheric dust content launching out like a blue whale and falls into a dust cloud, which you can see moving west. Sun stepping down into a grand solar minimum, solar cycle 25, 26. Low solar activity. The matchup in history, not much food was grown 1650. The Earth's going to need to equalize that charge. The sun does it, collapsing plasma causing coronal mass ejections. Our Earth discharging through the volcano's ribbon current system. Global electric circuit. Only one of the two new images after 24 hours that I've found of ash circulating in the southern hemisphere. A look at stratified ash layering in the atmosphere and how that is going to spread along the same latitude belts until it gets swept up to the equator, upward to 65 kilometers. And the middle range projections are putting at least half a degree Celsius cooling over the next year. And in part one of the video, talking about southern hemisphere reductions, Australia and the African continent, South America, Argentina is going to be greatly hampered by this, with so many of their crops in mid-season growth being affected. Looks like Joe hasn't gotten the virus or the economy under control. And now we have inflation and cron cases skyrocketing. And do you think the stock market will trade higher in the next 3 years than it did from 2016 to 2020? Economists are comparing our current inflationary environment to the inflation era of the 1970s. Gold was up 20x, silver 37x in that 10-year period. Learn how simple it is to add physical gold and silver to your portfolio ahead of the rise in inflation and predicted price rises. Patriot Gold Group has the no fee for life IRA, where your IRA or 401k can be in physical gold and silver. Call 1-800-356-4470 and get a free investor guide today. And with the knowledge that Patriot Gold Group is Consumer Affairs' top-rated gold IRA dealer from 2016 to present, click on the link in the description box below for more information. And now on with the video. Now, the mainstream media showing you the pretty pictures of the eruption, but not going into detail of what's really going to happen with our planet with this VEI-5 or VEI-6 eruption. We've seen the images, stunning to say the least, and the symmetry within the eruption as well. You almost need to ask yourself if there's some electrical activity involved in this. The density of the ash, and then where is that going to move to, and what effects will it have on cooling our planet and the effects on global agriculture. So we've seen the pictures, made news, there was a lot of tsunami warnings. This image itself doesn't do justice to the upper atmospheric ash concentrations along with the sulfur dioxide. And this image of before and after shows you how intense the blast really was to remove part of an island. Even the arsenals of the superpowers barely scraped the possibility on the upper end without cracking the planet in half. So I've had a fair few people ask me, where is Tonga? Well, it's where the red dots are there. Different islands. To the west is going to be Fiji, and then we see Vanuatu, New Caledonia. And if we continue west, Australia. Wind flows are heading toward Australia off this eruption. Interesting view here of the seismic wave that traversed the planet and pinged off stations all the way Yucatan Peninsula, Iceland, And the Canary Islands in a completely different ocean. We're going to look at a few animations in different wavelengths of light and infrared, spectral, and water vapor. And this concussion wave ripped through the atmosphere, the sea, and the crust itself. And you have to wonder, how high did those cloud tops actually go? And then what type of eruption are we looking at here? Canary Islands picking up the vibrations. At the same time, almost every station on the planet registered this event. Iceland Meteorological Institute, all their stations very sensitive due to the ongoing eruptions and monitoring of the Icelandic lava flows. So when we look at the event here, it's in the southern hemisphere, south of the equator. Now, most times eruptions don't pass through the equatorial band, but something of this magnitude will have a different set of variables versus even a VEI4, which is the Volcanic Explosivity Index, or a VEI5. So let's take a look at some numbers. Over here on Zoom Earth, I've linked everything in the description box below so you can chase down, do your own interactive, do your own research on this. But if we're looking at the ash, just the width of the eruption and then the outflows into the atmosphere of ash, we're looking at from east to west, 305 miles, and then north to south, about 321 miles. At the moment of eruption, not the ensuing ash spread, hugely different. So when I show you the satellite loops, you're going to be looking at the coordinates here, 175 west, 20 south. It's going to be right on a grid. It's pretty easy to identify where it is. So we'll identify the area right there at Hunga Ha'apai. This is a classical look in upper level water vapor. So up around 40,000, 43,000 feet off of this one here for upper levels. You can see the eruption and the subsequent descent of that ash column that flowed down and it swirls. You can actually see the size of it as it's collapsing expands outward. So if you go to the periphery of 175 east all the way over to 170 west, each one of these grid squares is 300 miles by 300 miles. So right now we're looking at least 900 miles, maybe 1,200 miles across, just from the ash when it rained back down and started to spread. Now, interestingly, it's being caught up in a cyclone that is moving toward New Zealand at the same time. So the winds are spinning in unusual directions due to the cyclonic action of these other more intense storms around the area. So you have to wonder, is it electrically induced? Because cyclone, which is known to be electrically activated for intensification, magnetic field lines, global electric circuit, is very close to, just a stone's throw. We're talking 300 miles, less than 1% away of the distance of the planet's circumference to where this event took place, and a cyclone forming at the same time and intensifying. So let's take a look at the tropospheric dust content. This will really set it apart. You can see the blast wave coming out of there, and it looks like a giant blue whale launching into the air. But here's where you can see the problems beginning to happen with our agriculture in real time in front of us. Slow this down for a second. But as that ash descends, gives you a better indication of the spread of it versus the water vapor. This dark black is so easy to see, and that's already spreading to around 1,200 miles in width of that ash fall. Now, this is going to continue to move across the ocean, but which direction is it going to move is the question. And if you keep your eyes down at the lower right where the colored bars are to show you the altitude of the dust, you'll see it's beginning to transit west, heading toward Australia. It'll cover Vanuatu and Fiji first. Huge ash falls there. And if we go over to the day cloud phase, this gives you another indication of the intensity of it as the shock wave rips out through the atmosphere, through the oceans, and many things that we saw with all the warnings that had been issued coastline based. But there you have the blue whale jumping out once again, and as it terminates and crashes back down out of the atmosphere, beginning to rain out the particles, the spread also is visible. Now the measurements in infrared and different nanometers for particle density all points to one thing. The wind flows, so this is off Null School. You're looking above New Zealand and a little bit to the east, or straight up that line to the right of New Zealand, and then you'll see Fiji is the first set of islands up there. A few hundred miles to the south and to the east is where that is. So these winds, those are at 70 millibars, which I'll say 40,000 feet. We'll put it there. I know it's splitting a hair between 38,000 and 44,000, but we'll leave it at 70 millibars up in the way upper atmosphere. Also, middle atmosphere is showing some of the same. So I put down a 700 millibars, which is the lower level in the atmosphere, up to about 15,000 feet or so. You can still see the trajectory is pushing west over Papua New Guinea and west into Australia. So I'm just doing some real simple measurements here. The Tonga Eruption you'll see on the right. The line over to Australia, Cape York, is where that ash is heading to. And you can see the cyclonic spin that's just north of New Zealand there. The cyclone mixed with this volcanic eruption, it has to be electrical, so close together in the crust. But I digress over to Cape York Peninsula, the Northern Territory, Queensland, Western Australia. This is where the ash is going to land in just a day or two. So just an early warning for those of you in Northern Australia, these water resource catchments are going to be greatly affected with ash contamination. Now, it's not going to be forever. The ash is going to come down. It's going to start floating on top. It's going to start sinking, mixing with the water column. Lakes, reservoirs, rivers, these things are going to be extremely ash dense for a little while until that sifts out. So anything used to filter this water is going to be incredibly clogged up. They're going to have to do maintenance repair operations on so many things using water with this much ash in it. We've seen the same thing in Chile and Ecuador over the years, where entire fish farms will be wiped out because the filters can't keep the water recirculating and they keep clogging with the ash. The fish can't breathe. This is going to be the exact same thing. There's going to be water difficulties in these catchment areas. And if we look over the same area of usage of these same territories, you're going to be focused on that flesh-colored pastoral lease land, meaning animal husbandry, cattle ranching, and anything ash covered like that. Well, the cattle aren't going to really like that. Again, water drainage regions in Northern Australia, all these will be affected. Ash covered. Now the density of ash, we're going to take a look at in just a second here, but it is intense. And how much of that is going to get caught in the upper atmosphere as well as the lower atmosphere and get pulled west. So I like these kind of older maps, something to look at here. Cattle and minerals. We're looking for the cattle ranching. And if you're a fan of gold mining or opal mining, you can find those points on the map. Just press pause in the video. That dark red East Coast, over 10 cattle per square mile. Those areas are going to have incredible difficulty continuing with their operations due to ash on the plants. We've seen this in South America many times. So let's move over to the electrical effects. I was trying to put these two together, and this is one of the best lightning plot maps I have seen in the entire event here. Each one of those sparkles that you see is a lightning flash associated with this discharge event from our crust. And the darkest of red in the center, it's almost like there's an outbound current flow happening. And at the exact same time, overlaying this on top of shortwave infrared, notice what happens. The electrical activity on the top right exactly matches with these cloud top activations and then dissipation at the same time electrically. Stunning verification that this is indeed an electrical event happening on our planet. Let's look at it a little bit slower. The eruption on the left there. The shock wave is just something to behold. Every time I look at these images and satellite views on the loops, it's mesmerizing. And especially when you look at the temperatures of these cloud tops. 80 degrees Celsius below zero, even higher up to 90, maybe even 100 degrees Celsius under. But notice how as quickly as they went to these heights and electrically activated, supercharging into the atmosphere with their height, they all drop off in intensity at the same time in the wave, if you will. Very strange to see that. And when we do look at images of these eruptions, it is humbling to see the power of our planet. And more of these eruptions are slated to come. Let's forecast a few out as we move forward here. But I wanted to dispute the ash height at which is being put out into the news feeds now. I do believe it's higher, and I will explain why. The current advisories putting out by the Volcanic Ash Advisory Center in Wellington, New Zealand, put it at 63,000 feet, which is right at 20,000 meters. So as I'm going through the infrared imagery off GOES 17, it shows you the dust and ash height and altitude. The purples are pushing 18 kilometers already, and then as we get a little bit into the more pink here, we're going to go down to 12 kilometers. We're going to start at the beginning of the eruption. We're going to move forward in time, and notice the intensity as this ash pushes higher and higher. And notice how the darkening occurs. What do you see? The black there, 20 kilometers and above. And then suddenly it's all 16, 18 kilometers. This is off Himwari. 2 sets of satellites measuring and observing this ash column increasing into the upper atmosphere. And then notices what is happening. It's getting higher, well above 20, and this is where it terminated. Well above 20 kilometers. And I thought, well, everything's pushing above 20 kilometers, so 63,000 feet on the call from the Volcanic Ash Advisory Center is low. It went much higher than that in the atmosphere. And doing a little research on figuring out how to get up to measurements as high as I could with the radio sound and see, Philippe Papin started to do this. He's saying possibly 30 kilometers deep stratospheric injection, given the satellite signature, and we'll take a look into the radio sound. So we're going to go way high up into the atmosphere, and it's pushing at 105 degrees Celsius below zero, which could be a record cold cloud top from a geostationary satellite ripped out from 2 years ago in the Philippines when a late season December typhoon, and that point was the highest and coldest cloud tops ever observed on our planet. You're looking for the pinkish intrusions coming out of the white striations on the east side of the eruption. This will give us some measurements that are pushing well into the 80 to 90 to 100 degrees Celsius below zero. And at the pinpoint at the epicenter itself, we're rising well up into the 100 degrees Celsius below zero. And it's all about this ash moving west. So I did pull up the station NFFN, which is in Nandi, Fiji, for the readings into the upper atmospheric temperatures. And I'm going to be conservative and say 50 degrees below zero still puts it at 26,000 meters. Now this is off the charts, literally at 105 degrees Celsius goes way off that chart. You're going to have to add another band at 100 and then 110 so you can encompass. But you're going to go well into the 26 to 28,000 meter range, which puts it way up at 100,000 foot on the ash. This is getting close to Pinatubo. So I slowed this down, the cloud top infrared, and it shows you the degrees in Celsius. And at the termination point, you can see that bullseye in the center of the eruption where the extreme cold happens. And there's so many missing frames. Everywhere I'm looking, there's missing frames. I've strung this together, cutting out all the empty frames. Now you'll see the timestamps have jumped in between each other. So ultimately, 700 Zulu, we're looking at the cloud tops here. That lighter gray ash versus the very bright white. The darker gray ash is up around 90 to 100,000 feet. Now looking at the density of it, this is where it gets interesting. Himwari's pulling this at least 10 grams per square meter. Incredibly dense. So we got to put it into perspective. What's going to happen with our global agriculture here? This comparison of temperature versus cloudiness, Pinatubo is listed more cloudiness or ash in the atmosphere results in decreasing temperatures. So following the crop losses that we're experiencing this year, the fertilizer shortages, the herbicide shortages, the trucking shutdown from cross-border trade in the United States and Canada, knowing Australia is struggling to keep its agricultural production up, along with South Africa and parts in South America, this is where it will be affected most greatly first. Ash is one thing, sulfur dioxide is another thing. So far, it looks as if forecasts are coming out for a 0.3 degree effect based on the impacts of this eruption. Now, this is just one set of variables going on, but if you didn't know, I'm going to run you through the past for, say, the last few months. There's been an enormous amount of high-level eruptions across the planet, starting right here with the same exact volcano that put ash 50,000 feet back on December 21st, 2021. That is the day of the solstice of all things. It actually ended up being 55,000 foot eruption. And for comparison, this is a 55,000 foot eruption, and that's all the larger it was on December 20th, 21st, compared to the one we just saw. And if you do look almost dead center, you'll see that streaking, looks like a smokestack coming out. That is the same volcano releasing ash. Taking you over to ash RGB. This will give you a good indication of the sulfur dioxide that's coming out of that event back in late December 2021, the 20th. That is nowhere remotely close to what we just saw. That is orders of magnitude far smaller. But then the Philippines and Taal also had quite the large eruption, and we've seen a string of these across the Aleutians, Kamchatka Peninsula, Alaska, equatorial eruptions in Indonesia. But these are the kind of the ash blasts that we're looking at. In the image here, you might think it's massive, but it's only at 50,000 feet. What we just saw is double the height of this. Now, what would explain this, and can it be forecast out for more intensities? This is the most important part for you and I, keeping our families safe, getting ready for these changes. So through the inception of my channel, Adapt 2030, I am just following the astrophysicists coming out saying that we are heading into a grand solar minimum terminus point of solar cycle 25, and solar cycle 25 might not be as intense as forecast. To be seen. We don't know until it's finished. So you can't say anything's incorrect until it's over. But anyway, most astrophysicists, including NOAA and NASA, grand solar minimum, solar cycle 26, looking at a maximum sunspot of 20 or under, even some months during maximum with only 6 sunspots. That's their forecast. NOAA and NASA, not mine. So if you start to match up chapters of history, you'll start to see 1650, through that era of 40 years, there wasn't much food grown, there was upheaval in society, economies changed, population migration, and we're in it again. So can we forecast it out? Because it's all based on solar activity. And here it comes back to the electric effects again. This is definitely an electrical discharge off our planet here, in my opinion. So solar maximum, solar minimum, you can see the intensity of the sun, how it does increase and decrease its activity every 11 years. What causes that? Again, it has a wave pattern to it. And if you know the electromagnetic connections between the sun and our Earth, that things are connected. And when we step out to October of 2024, the Earth will be between that set of 4 gas giants that only has this particular configuration, last seen 79 AD and 1486. The Earth will be between the sun and that second magnetic field forming with this strange square configuration of our gas giants. But as we sit today, the Earth is going to start to swing around the sun and indeed enter that magnetic coupling in close proximity of that square forming with these gas giants. Expect more volcanism, especially through April and May, as the Earth now responds to several different inputs into our atmosphere and the crust itself. Now the sun, you can see the magnetic looping. It has a way to discharge and equalize. These magnetic field lines snap, coronal mass ejection, or sometimes a filament rope will land on the sun and then be ejected off of that. So think about our Earth as an electric motor. There's a charge potential difference that, well, makes our planet spin in its orbit. We have a core. So if these two charges are equalized, and we've gone hundreds and hundreds of years, centuries or millennia, with the same equalization state as the sun and its electromagnetic output, if something were to change in that, then our Earth would also need to discharge to equalize. This makes sense in the Earth's global electric circuit. There's a current flow from the crust through the atmosphere to the ionosphere or far high level when we're getting up to the edge of space and then reconnecting back out to the sun. It seems that this global electric circuit is now becoming far more active and identifiable where these outflow and inflow points are. You got the thunderheads and storm building cumulonimbus rolling up to 25, 30, 35,000 feet, discharges the lightning to the ground itself. But when we get above that, we have the red sprites, and then we have the elves. And right there, that circle you see is a magnetic field line of the Earth being wrapped by electric current in glow mode, so you can actually see it, that plasma glowing. So this ribbon current system is the one I'm referencing here, mid-latitude. That's exactly where these eruptions took place. So think about it as electrical discharge out of our crust following these same magnetic field lines outbound. That's what you're looking at right here. And it's so interesting the way that it's setting up where you can almost see the current looping on top of itself. And if we're going to talk about these magnetic field lines, Birkeland currents, we have an outer hill system as well. And where would that be? Northerly latitudes. These types of eruptions in the northerly latitudes, 60 to 90 degrees north. We're seeing it everywhere, and perhaps this is the mechanism of why there's so much volcanism when the sun steps down, and this peer-reviewed research showing connections between grand solar minimums, decreases in solar output, cosmic ray increases, and volcanism as well. So if this system of magnetic fields were to decrease instead of increasing in strength, increasing would lock our magnetosphere into place and we have tighter jet streams, tighter cloud cells, but go the inverse, main current decreasing in strength. The same exact thing will happen on our planet, and it will need to discharge that over potential outbound. I think this is what we're seeing, and I think this is the cause of these types of eruptions. Where does that take us ultimately? To 2024 October. Because the Earth has swung around and will be more locked into this second magnetic field in the outer solar system moving forward. The effects of this, and Theodore Landscheid had done an enormous amount of work on how these gas giants affected the Earth electromagnetically. And each year we move forward, we're going to get more and more into this field, culminating October of 2024. So this is where it ends up. Second magnetic field in the outer solar system, the Earth sandwiched between a decreasing magnetic output of the sun. Perhaps that's why there's so many distractions going on, because when you look at looping toroid magnetic fields and the effect it would have on a planet in the block wall, it all makes sense why things would be happening. If food's going to be more limited, you would need to control the population. And some beautiful sunlight passing through the ash, continuing to spread across the southern hemisphere. Now in 24 hours with one of the largest eruptions in the last 30 years, you'd think there'd be far more images out there, especially with the International Space Station circling around the planet every few hours over these same areas where the ash is spreading. Trajectory west off of Australia. But after 24 hours, I found 2 new releases from NASA. It's always the same images, just recirculating again and again. 2 new images. The best tech we have, the best visual imagery, satellites, and real-time camera views. And this is all we get, 4 images stacked. The bottom layering was from yesterday. What is going on? Why are there not so many images? I could put out some of my own ideas, especially when you start to look at this stratified ash layer modeling that they're doing now. Notice the black dashes there on the glass. And mimicking the eruption, where's the bulk of the ash going to stay and spread? And in turn, what type of acid rain is that going to drop on the crops? What type of sunlight is that going to block out in our main crop growing areas? And how much do you think it's going to decrease the yield moving in? And then those nations reliant on importing food from the same areas, decreased yields. Some nations are not going to get the full allotments this year. That is for sure. And looking at Null School here, you can follow the winds right from Australia over to Africa. and we'll see how it transits after it passes southern Africa, but it will head over into South America, Brazil, Argentina over the next 7 days. Now, one thing to think about this with atmospheric wind circulation, that center lighter blue line is the equator. And if you go up toward France on that map, that'll take you to 30 degrees north latitude. And if you go south to where it says southeast trade winds, down to that blue line terminating at the Farrell and Hadley cells on the right, that'll take us down to 30 degrees south latitude. But notice where the winds are pushing. The eruption was at 20 degrees south latitude. So much of the ash is going to be directed toward the equatorial bands. The Farrell cell is going to sweep a little bit up and pull it more south. This might give you a little bit better imagery here on how the winds are going to sweep this ash and sulfur dioxide into different areas across the planet as this unfolds over the next months, plural, and I do mean 2, 4, 6, 10 months in the future. A lot of it's going to get stuck in that 30 degrees south latitude up to the equator, and it looks like it absolutely is going to surpass and go over the equator into the northern hemisphere. Westerlies are going to pull it back and take it even further south. Not so much crop production from 30 to, say, 60 degrees south latitude. So most of the reductions are going to occur between the equator at 0 and 30 degrees south latitude. And speaking of atmospheric disturbances, let's talk about gravity waves. Visible, how the atmosphere was moved. And not being widely talked about either are the perturbations from this event as well that will ripple around and continue to have some sort of effect on the atmosphere circulation patterns. That was a very large disturbance in the atmosphere. Now, how long will it take to play out and everything restabilize again? This is brand new research. Hence, the beginning of the video, why are there not more images coming out with this massive event when we have all the tech to give us such images? And the umbrella is going to continue to spread like they did with the modeling and the pink plumes in the water column to mimic that. Plume top 55 kilometers, that is, through several other reports I'm reading, maybe going to be revised up to 60 to 65 kilometers. So we're looking at the upper umbrella through the bottom layering where it would maybe terminate at the lower plume. That is going to continue to spread. Incredible imagery here, looking at that center column poking through the umbrella of ash. And now so many estimates are coming out. The minimum range that we're looking at for cooling is 0.5 degrees Celsius. I'm willing to go on the record to say that. Others are going to put it down at 1 degree Celsius cooling. Be prepared for 0.5 degree Celsius cooling globally. A lot of the effects are going to be right in this band that I put on the blue map here. 20 south is where the eruption took place. And we're going to have that mixing, as you saw in the atmospheric circulation. And over time, this is going to get drawn toward the equator. But for these very first few weeks and months, a lot of the ash, sulfur dioxide, is going to thin itself through this area of the box on the map. So I have to look which countries are there and which ones produce food for our planet. And all centennial here. Sulfur dioxide, as we saw at the eruption several days ago, moving through Australia, crossing Australia, passing over into Indian Ocean and on its way to Africa. If you want to find any of these images, just head over to Twitter specifically and put in some of these hashtags, Centennial5P, Tropomi, and you should come up with a bevy of different information and graphics. So what they know so far is this sulfur dioxide plume from Australia, and not even at the origination point at Tonga, which is some thousands of miles even further. So far it's 7,000 kilometers long, heading from Australia, just starting to touch into Africa. Those of you in the States, multiply everything by 0.6 to get the miles, 4,200 miles. And you can find this one over in the Copernicus database. This one will show you the total mass of area covered from the eruption so far as this continues to spread. And it looks like 698,000 square kilometers so far is the area covered. But this will continue to spread, and that'll go well into the multi-millions of square kilometers of coverage. That's why I'm saying that these areas that I've marked in red on this map here are going to be the ones that encounter some of the greatest yield reductions in the southern hemisphere. So I did cover Africa and Australia yesterday in part 1 of the video series. I encourage you to watch that. I'm going to jump over here to Brazil and South America to see who are the countries that rely on the South American exports for their foodstuffs. Brazil, massive exporter. Asia, China. The harvest and planting season is predominantly in these next 2 months. So the effect is not going to be as great as areas that are in full mid-season and the plants are maturing. Now the planting dates in the first emergence, that will have a little effect, but not as if it's in mid-season when the plants will be struggling when they need nutrients, sunlight, and these inputs at the most critical time. And we're just unsure how precipitation patterns are going to move with all this sulfur dioxide, acid rain, different ash, and what that will affect with rainfall patterns. And speaking of rainfall, the Brazilian soybean crop forecast lowered a little bit because of the drought. Now, will this ash bring more rainfall? What we have to look to in the past is more of a Pinatubo style, but for the southern hemisphere. And looking at the oil seed and soybean exports, Brazil obviously in the number 1 there, but Argentina number 2. Which brings us to Argentina, and this will be the country with the greatest declines in yield across the board. Everything is in the mid-season at the moment. Everything being grown is going to be reduced because of the lack of available sunlight and all those stresses on the plants right now when they're coming into maturation just before the harvest season. And then in addition to that, some of the wildfires, and you can see the map top right, that is already particulates that are up there blocking sunlight. Now we're going to add another full layer, and I'm not even talking about the geoengineering, strictly ash, sulfur dioxide combining with this particulate from the fires, and also our friends at higher altitudes in airplanes from Harvard, Oxford, NASA, and private organizations worried about Earth's temperatures too. Major exporters of corn, who do I see there? Argentina. Who relies on that? China. Also factoid here, sorghum exports. China reliant on Australia and Argentina, both going to have reductions in yield due to this event of the eruption in Tonga. Moving over to Chile, also far south. Since it's already coming into the harvest season, except for rice, everything's going to be right on track there. I don't foresee much happening in Chile. So it'll all be down to the corn exports, which on the map, Brazil, Argentina, major players that are going to have some reduction, as well as the wheat. A lot of that's outbound for China. So as this ash continues to push further toward the equator, got Uruguay and Paraguay. These are kind of wild cards. Not sure how fast this is going to have an effect due to the southeast trade winds pushed by the subtropical high. But with the fertilizer shortage, herbicide shortage, supply chain breakdown, and now this ash across the southern hemisphere reducing yields, things are going to get a little expensive on the food side. You might want to prepare a little bit. And I will combine this with part 1 to do a full-length video here so you can watch it all in one go. But if you're thinking about storable foods, 3-month emergency food supply, My Patriot Supply and Adapt 2030. It's a great way to support the channel. That link's in the description box below, along with the links to all of tonight's images, stories, feeds, so you can do more research on your own. I appreciate you watching. Hope you got something out of the video, and I'll see you next time.